Welcome back. Continuing, let's talk about operations, functions, and algorithms. The hardware component that controls the entire computer is known as its central processing unit. That is the CPU, Central Processing Unit. Commonly supported instructions are, so what happens in the CPU? You load data from main memory. Remember, main memory is random access memory. Okay, that's main memory. All right. So you first load data from main memory into the CPU, or you store data from CPU to main memory. So these are important instructions, right? Operations. Then performing basic arithmetic operations or checking basic Boolean conditions. Boolean conditions. Boolean means the result is true or false, right? So arithmetic operations or Boolean conditions. So these are the kind of things that are worked in the central processing unit. Just as data types can be built in or user defined, operations can also be built in or user defined. So when you define a class, you will define data types in it and you will define operations on it. Okay. Otherwise, you always have the built-in options. In addition, there are control structures which determine when other instructions can be executed or repeated. For examples of control structures are if, elif, else, all right, or for loops, while loops. Okay. Now, algorithms. So what is an algorithm? An algorithm is a step-by-step procedure for solving a problem or accomplishing some end, especially by a computer. That procedure is called algorithm. Okay. For example, here is an algorithm. To find the greatest common divisor, that is GCD, of two positive natural numbers. Here is a flow chart. What is a flow chart? Well, you're starting here, you go there, start with a guess equal to the smaller number. So you want to find GCD of two numbers. So let's have an example here. Okay, I'll follow the flow chart while working with an example. So the example I have is find the GCD of 36 and 48. So our two numbers are U, let me call them U, V. Okay, and it seems I'm going to have a guess. All right. So to begin with, my two numbers are 36 and 48. All right. So in the very first opening statement is opening implementation is I'm going to put guess equal to the smaller number. So my guess is going to be 36. Okay. Now you go down. So that's a flow chart. I follow the arrows. So I have implemented this box. I go down. When I hit a diamond or a rhombus, you see, this is what is called conditional. So I have a Boolean expression. So does my guess evenly divide both sides? Does my guess evenly divide both of these values? No, it evenly divides U but not V. All right. So no is the option I have to choose, not yes. So I go this way, and my next statement is reduce the guess by 1. So I need to reduce the guess by 1. My U is the same. My V is the same. I have to reduce my guess by 31 by 1. So that gives me 35. So that I've implemented this box. So I go here, which leads me back down because that's the direction of my arrow. So that's the direction of my flow. Now again, this is a Boolean condition. I'm checking. Does my guess evenly divide both values? So this is my guess. Does it evenly divide both values? No. So I go back. I have to reduce my guess by 1. So no change here, no change here. This has to be reduced by 1. Do you see? There's no change going to happen for either u or v, because my algorithm does not require me to. All it does in every step is reducing guess by 1 if my current guess does not divide the numbers evenly. So here again 34 does not divide these guys. So let's go back and fix these. Reduce by 1. So again check, again check. So keep going. You see, this procedure by now you have noticed is quite inefficient, but it is an algorithm. Okay, so this is an algorithm that goes on. What is the, you know the GCD of 36 and 48. Do you know the GCD of 36 and 48? GCD of 36 and 48 is 12 actually. Okay, 12 times 3 is 36, 12 times 4 is 48. That's the largest number that divides both equally. So you started with a guess and kept reducing. Now you see how many steps it will require. Okay, you keep doing this. At some point you will have 36 for u, no change of u, 48 and 12 as your guess has been reduced going down. Does it divide? Yes. That's when you get out. You get out of this loop. Okay. So this is an example of a beautiful flow chart. It gives you how your algorithm functions. Okay. You found your GCD. Okay. Now, here is a more efficient algorithm, that is the Euclid's algorithm. You have probably learned this in your CSI30 class. Regardless, what is Euclid's algorithm? Okay. Initially, set values u and v equal to the original numbers. Okay, so let's do that. So now you are going to work with Euclid's algorithm. Okay, you have u, you have v, and who else? Looks like I have u, v, v, r. There is some other guy called r. So let's figure out what they are. U was 36, v is 48, r I don't know. So initially I have set u and v equal to the original numbers. Go down. Is v 0? No, it isn't. So what do I do? It's no. So divide u by v, letting r be the remainder. So I'm going to divide u by v. Do you understand what that means? It means, let's do this some distance away. I'm going to divide 36 by 48. Okay. Now, if I want to do this the long division way, you see what that means is you're going to have some kind of a picture like this. 48 is on the outside and you are going to have, let's see, 36 on the inside. That's a long division. Okay, I hope this is clear to you. How many times does 48 go in 36? It goes in 0 times. What does that mean? It means I have to subtract 0 times 48, 0. Okay, so that means I have subtracted nothing. So that gives me remainder to be 36. I hope this is clear. 48 is bigger than 36, so it goes 0 times. When I subtract, so that is my remainder. All right, so keep that in mind. So remainder is 36. All right, which brings me to reset u and v to the values v and r respectively. So u now becomes v and v now becomes r. All right, so the purpose is to make sure that the first number is bigger. So you see, we achieved that. Now do the same process. You go back. Is my v 0? No, it isn't. So divide u by v. How many times does 36 go in v? 36 go in 48. It goes in it once. And what's the remainder? Remainder is 12. All right. 36 goes in 48 once. And the remainder is the difference. Okay, so that's good. What's the next step? You did that. You come back. You go after doing this. Reset u and v. So now my u is the new v. My new u is the old v and my new v is the old r. Okay, go back. Is v 0? No, it isn't. So divide u by v. How many times does 12 go in 36? 3 times. What's the remainder? 0. All right. So you did that. R be the remainder. Go back. Reset u and v. So my new u is the old v. My new v is the old r. You go there and come back here. Is v 0? Oh yes, fantastic. V is 0. If it's 0, the current value of u is the GCD. All right, so v is 0. So the current value of u, that is 12, is the GCD. You see? So Euclid's algorithm within how many steps? 1, 2, 3, fourth step already gave me the GCD. Whereas the original guess method was quite inefficient. I stopped working here. If you notice, I have to keep reducing by 1 until I hit 12. Whereas Euclid's algorithm, within a few steps, I got the answer. Mind you, when you work on GCDs, these two numbers were easy numbers. You could have large numbers. You could have had very large numbers. Find the GCD. Euclid's algorithm is very powerful. All right. So this is the flow chart for Euclid's algorithm. Okay. Now, I went through one example. I'll ask you to go through one more example by yourself. Okay. So until the next video, I'll take a break now.